So we've learned how to add and subtract and multiply and divide with rational expressions. So now we're going to start doing equations with rational expressions. There's some good news here and there's some bad news here. The good news is that the basic technique is a technique that we're very familiar with. We've used it for a long time, ever since the beginning of Algebra 1, and it's the technique you use for clearing fractions out of an equation. Like in this example here. If you don't like that this equation has fractions in it, you can multiply everything by the common denominator, which is 40. And then, since you get to go 40 times each one of these fractions, you get to do a lot of reducing. 40 times 4/5, you cancel 8s, you get a 5. 40 times 3/5, you cancel 5s, you get an 8. And 40 times x over 10, you cancel 10s, you get a 4. And the important thing is, that means there are no more fractions anywhere in this equation. We have a regular linear equation that can then be finished up normally. So that technique that we used for that sort of a problem, that will work here in Chapter 6, because really the only major difference is the problem I've just looked at. The denominators here were all numbers. Compare it to this problem here, one of the denominators has a variable in it. But the same basic idea will apply. You can multiply both sides by the common denominator, and that will clear out the fractions. Common denominator here is 40x, and just like in the previous problem, you distribute that 40x to each fraction, and you get to cancel. And the cancellation works just as well here as it did in the previous problem. 5 goes into 48 times, 8 goes into 45 times, x cancels x, that's the new thing. Back in Chapter 2, we never would have canceled x's, but here in Chapter 6, canceling x's is no big deal. And we're left with, let's see, 8 times x times 4 is 24x, 5 times x times 1 is 5x, and 1 times 40 is 40. We're left with a fairly simple equation to solve. So the basic technique is a fairly simple basic technique. Multiply through by the common denominator, that will clear out the fractions, and then you can proceed normally. One of the more complicated things that we run into here in Chapter 6 is that when we say, you then proceed normally, well, we've learned a lot of things since Algebra 1. Here, take a look at this problem. The common denominator is really obvious. There's only one denominator, a. So we're going to multiply both sides by a. But take a look at what that does. A times a, we get a squared. So one of the lessons here is it's possible to get a quadratic partway through one of these problems. Don't panic. Just solve the quadratic the way you would solve any other quadratic. Get the thing equal to 0 by bringing that 4a over to this side. Then factor it. A plus 3, a plus 1. That breaks up into two separate little equations, and you solve each little equation. You get a equals 3, or negative 3, sorry. A equals negative 1. But I don't think anybody's going to be too shocked by this complication here. Clear your fractions out, same first step, and then solve whatever thing you created, which might be quadratic. They won't always be linear at this point. But there is definitely some very bad news here in section 6.6. And the bad news, the best way I can show you what the bad news is to walk into it carefully through an example. So I'm going to warn you, you're going to want to follow this example very carefully because there's some danger lurking in this one. Okay, so approach it with the right idea in mind. Okay, let's see. What did we just do? We cleared fractions by multiplying by the denominator. Well, in this case, that means I'm going to multiply both sides of the equation times x plus 2. So that x plus 2 is going to get multiplied by 1, which will give you x plus 2 times 1. x plus 2 times this fraction, the x plus 2 times the denominator of x plus 2 will cancel, and you'll just have 3x. And then same cancellation idea happens over here. The x plus 2's cancel, and you have negative 6. Not too bad so far. I didn't want this part to be too challenging. This looks okay so far. Collect your like terms. This is looking like a pretty simple equation, isn't it? Subtract 2. Divide by 4. And everything seemed to work very smoothly. This is what's dangerous about these rational expression equations that we have here. The work can be very simple, easy to understand, all the steps, you're quite confident you did the steps right, but then remember what you're supposed to do at the very end of most problems. You're supposed to check it. We think currently that the answer is negative 2. Let's check it and watch what happens. That means take the equation, and everywhere there's an x, put in negative 2 instead. So all those places where there was an x, I'm going to put minus 2 in there, and then I'm going to work out and see if those come out the same. Do you see the problem? See what's happening right there? You can't divide by 0. So, this is not something we could have run into before Chapter 6, because up until now, we never had variables in denominators. Now that we have variables in the denominator, it's possible that when you plug a number in for that variable, the denominator could possibly come out to be 0, and that's not okay. The answer we thought was going to work here, negative 2, it doesn't actually work. We actually have no solution to this equation. And this business about doing all the right steps and getting what looks like the right answer, but then it doesn't check, what this forces on us is this forces a brand new rule. And here's what the new rule is. The new rule is, and this only applies to these rational equations, but the new rule is you must, not optional, must check your answers on paper. And it's such an important rule that I'm going to actually do the following enforcement of the rule. Anytime we're taking a test, if you're solving one of these rational equations and you don't write down the check on paper, you will get half credit off of your problem. So let me write that down. You will lose half credit if you don't check on paper. I know that in a lot of cases you can check in your head, like in this case, if you think x is negative 2 and you just look at the equation, you can see that that denominator is going to be 0. I know you can check in your head. I can check in my head. That's not the point. The point is not whether you know it works or not. The point is, knowing whether it works or not, actually checking, is a required part of the problem. So if you don't actually write it down, I don't know that you even thought about it. I can't read your mind. I can only grade you based on what you write on the paper. So you have to write this check down on paper or you will lose half credit. That's absolutely essential, super important. In order to really get that idea down, let's do one more example. So this is one of those sorts of problems where you might want to pause the video, try working it yourself, and then I'll work it out, and we'll see if we get to the same place in the end. All right, so we're going to multiply both sides by the common denominator. Well, to figure out what the common denominator is, it's a really important first step to factor any denominators that need to be factored. And then you can see, oh, the common denominator here is t minus 3 times t plus 3. So I'm going to multiply both sides of the equation times t minus 3 times t plus 3. So over here in the first fraction, when I multiply this times that, the t minus 3's will cancel. I'll still have the t plus 3, and I'll still have the 5. In the second fraction, both of them will cancel. T minus 3 and t plus 3 will both cancel, and I'll just have the 30. And on the right, there's no denominators to do any canceling with at all, so I have both the t minus 3 and the t plus 3. So do some distribution here, do some foiling out over there, and you should have 5t plus 15 minus 30 equals t squared minus 9. Don't forget to collect your like terms. So we have 5t minus 15 equals t squared minus 9. And notice with the t squared there, this thing is quadratic. So with quadratics, you want to get them equal to 0. I'm going to take the 5t and the minus 15, and I'm going to move them over to the right-hand side of the equation. So I'll have t squared minus, oops, almost wrote 15, t squared minus 5t, let's see, plus 15 minus 9 will be plus 6. Then factor t minus 2, t minus 3, and that gives us what appears to be 2 answers. But remember, you have to check. Checking is required. You can't just do it in your head. You must check. So for the 2, I would have 5 over 2 minus 3 minus 30 over 2 squared is 4 minus 9. So that's 5 over negative 1 minus 30 over negative 5. 5 over negative 1 is negative 5, minus a negative is plus, 30 over negative 5 is 6, and negative 5 plus 6 is indeed 1. And then when you try to check the 3, you run into a problem almost immediately. In fact, you don't have to go any further. As soon as you can see that there's a denominator that's going to be 0, as soon as you've written down that that's going to happen, that's all you need to do to show that that answer is not really an answer. 3 would not work if you plugged it in. So please remember, if you are solving a rational equation, checking at the end is worth half the credit on the problem. Even if you have the right answer, if the checking was not written on paper, you will get no more than half credit.